Speech production. I will talk about the source filter model, about spectra, about F0, performance, F1 and F2, and vowel space, and consonants. Yes, we have I will talk about the vocal fold, and not much anatomy. We have the vocal fold. There are two folds separated by a glottis. It can be closed and open, and this area of the glottis is opened. The period, they are making some voice like a string, you can say, on a guitar, and it has a period of 4.5 milliseconds for women. It means a fundamental frequency about 220 hertz for women. For men, it's about 120 hertz. Sometimes it's mentioned 210, but it's just a simple calculation. Yes, and it's because of the area of the glottis. We have the area in time, closed, open, closed, and so on. And it makes a spectrum. And we have the fundamental frequency here. We have a spectrum, so it's frequency and dB. It could be 100. It could be maybe 60 decibels or something. I'm not sure about that. And it decrease about 12 dBs per octave. So the source is vibrating poles, fundamental frequency F0, and pitch of voice. This is source spectrum. Yes, and we can have a filter. We have a model. We use a model now, approximation model, with a vocal fold here, a vocal tract. Here's a mouth, vocal tract, and this is about, for men, it's about 70 centimeters grown up. That means the velocity of the air is minimum at the end, closed end, and maximum here, and the opposite for the pressure. Yes, and you can say there is it's called I think poles. So F is C divided by 4 times L. That gives 340 times 0.6 and about 500 hertz. That's the intensity hertz. As for first one, this is F1. F2 is 3 times, in principle, I call it 5,500, and then cost 2,500 hertz. So you can say the vocal fold tracks are forming the spectrum from the vocal tract to a new spectrum, and it's formed like this. You can say it's in spectrum is like this. So we have the F1 here, F2 here, and then a lot of smaller frequencies, and F0 here, fundamental frequency. So the vocal tracks, I will not draw it. It comes through the lips output. Lips, it gives some time time and pressure, some speech, you can say. Again, the source filter, frequencies, yeah, and then the hertz, and then the decibel, and then decreasing, and therefore also the formats are decreasing. And this, you can say, in vocal tract, yeah, 500, 1500, and then we have the speech output. F1, frequency and hertz, no pressure, dB. Yes, that's it. So you can also, I will go to the vocals. There are 9 in Denmark, and there's some those formats. Yeah, I can say that the filter is a resonance of vocal tracks. Resonance makes the formants and phonemes also. The smallest sound unit that can change the meaning of a word. Yeah. We have this heat, for instance. The read and read. There's a difference between the written and the spoken language. Heat, it should be in front. Heat, read high, and yes, here we have high and low. This is the first formants. The second formants F2 here is front and back. So that means high is front a big, about 3000 or something like that, and 1100 or something like that, 200, 300, I can't remember exactly, and then 1000 maybe. Yeah. So, and different, you can make this vowel space. Here we have for women and for men. Law, altså, here we have heat. Law could be law, it should be back and low. Law. So it's law for men should be here, maybe law, hard, oh, here. There's a smaller F2, but a bigger F1. Yes, okay. And then that's it. I will talk about it's because of the constrictions. You change it's called formant transitions. Then you can also have the consonants. And what is making the consonants? There are some where, and how, and voicing. P, B, T, D, K, G. What I can remember. Alveolus P, B, T, D, alveolus, and K, G, velos. Here's voicing, and here's no voicing. And that's for now. That's what I can remember. Yes, thank you very much.